In this video, we're going to look at a special type of function called a direct variation. A direct variation is a relationship between two quantities or two variables where one of those quantities is a constant multiple of the other. When one quantity or variable changes, the other variable changes in a proportional way. So if my two variables are x and y, as x increases, y also increases at a constant rate. If x decreases, then y is also going to decrease. So the variables move in the same direction. As one gets bigger, so does the other. And when we look at our equation for direct variation is always going to be of the form y equals kx, and k is called the constant of variation, or that multiple that we keep multiplying by each time. If we want to solve for k, we can just take y and divide it by x to get that k value. And that'll tell us what we have to keep multiplying our independent variable by in order to get our dependent variable. There are three different ways that we can represent direct variation. The first that we saw is the equation. The second is the table. If we're given a table and we want to check to see whether it's a direct variation, I like to add kind of a third column, and we can find our k value for each row and make sure that it's constant. So here we have 4 over 1, 8 over 2, and 12 over 3, and all of those are equal to 4, which comes back to our equation, y equals 4x. And if we look, we can see that x times 4 equals y. So times 4, and that works all the way down. If we look at our graph, the first thing we want to point out is that our graph passes through the origin. All direct variations pass through the origin. If your line is shifted down and it passes through -3 or up 3, it's not a direct variation. It must pass through the origin. Then if we look, we can go to the point 1, 4 on the graph. So as x increased by 1, y increased by 4. And that would remain constant if we were to extend our graph in both directions. So the first thing we want to do here is see if we can identify which of these tables represent direct variations. If we look at the first table, like I said before, we can just add that k column, which is y over x. Here, -18 divided by -3 is 6. -12 over -2 is 6. Here we get 6. Remember that each direct variation passes through the origin. So if we see 0, 0, that's a good sign. Remember that I can't divide anything by 0, so I can't do 0 over 0. So we get 6 here and 6. So this is a direct variation. Now, in table C, we don't have any input of x equals 0. That doesn't necessarily mean that we're not dealing with a direct variation. It just means that this table doesn't include that point. If we look at table B, when we plug in 0, we get -6, which right away that's the only thing I need to see to let me rule out this table as a direct variation, because it does not pass through the origin. So go ahead, pause the video, and see if you can identify if either table C or D are direct variations. Alright, so if we look at this one, table C does work out because y over x is constant for each row in that table. So our constant of proportionality, or our constant of variation, is -3. But if we look at our next table, y over x is not constant. So that one is not going to work for this particular direct variation. I don't know what's happening with that pen there. Right, so when we want to graph direct variations, for right now we're going to use a table. And just the same way as we graphed function rules before, we want to make sure that we get a good representation of what this picture looks like. So you can use your graphing calculator. If you forget how to graph, remember we start by going to the y equals screen, we type in our equation, and then we hit graph to see what this looks like. If you want to just copy the table straight off the calculator, you would just hit second, graph, and it'll bring up your table. Remember that, again, we want to include positive values, negative values, and it's always a good idea to include 0. So if I start my table here, keeping in mind that we want to be able to fit our points on this graph, we can do -2, -4, -1, -2, and so on. So now I just go and plot those points on the graph, and we'll be able to see what this looks like. Let's start with the first one. Keep going. And we're going to connect the dots here because we want to graph the whole function, even the points that we would have to estimate where they are. And again, we include the arrows to show that this graph continues in both directions. These are typical problems you may see with direct variation. They're always going to follow the same format. even if it's just a problem with y and x or a word problem, you're always going to look for the phrase varies directly with. Whatever comes first before that phrase is going to be your y. Whatever comes after that is going to be your x. So here we are given that y equals -4 when x equals 2, and we want to find y when x equals 6. So the first thing I want to do is find k. So I take my numbers that I have, I plug them in, and we get -2. This means that our equation would be y equals -2x. So we can go ahead, plug our new x into that equation, and we'll get our new y coordinate, which is 12. Go ahead, pause the video, see if you can answer the second question on your own. Alright, so if we read through this question, we find our varies directly with, which means that the total cost to fill up a car is going to be y, and the number of gallons we're buying is going to be x. So we plug everything in, we get 2.25 for our constant of variation, which gives us an equation of y equals 2.25x. We substitute in our $18 for y, and when we solve for x, we get 8 gallons of gas.